listening. We're really excited to have Gary Clark with us. Gary is the regional leader of science and technology at HOK, where he works at the London office, and he heads up over the UK, Europe, and the Middle East. Gary is also an authority on green design and regularly advises the government on sustainable policy. He's also the chair of RIBA Sustainable Futures Group and the author of the RIBA Sustainable Outcomes Day. Also, Gary is an alumnus of the Scottish Southern School, and he was actually in the usual friend of Vincent.
Thanks for bringing me to be here. So just working out that last time I sort of did 5710 was 5 years ago. So the good thing is that I think you guys have forgotten what I said 5 years ago. So it's just actually just the tutors that I'm afraid you're going to hear it all again. So, but at least there's some new slides anyway. So right, the talk is it's basically it's done a few parts. First part is obviously we're going to touch on the emergency and what's happened in Glasgow, and then it's really just give you a bit of background in terms of my influences, and then what that's kind of sort of led to the way I approach architecture, and then how I've been thinking about sustainability. I think right from everything I do basically. Then I'm just going to go through just a little few projects, and it's going to be a little little moments of where I've come close to what I'd like to do, but I would say that I haven't really achieved what I'd like to achieve yet. So the great thing is now I haven't felt a surge like this for many years, and I don't think it's ever been as good as this in terms of the message I've been saying for 30 years is now resonating with lots of students, which is great, but also government and my peers in terms of the architects. So back 30 years ago, there wasn't many people actually really doing this. So it's great. So I'm really going to join my last section of my career, basically. So it's going to be great fun. So right, so just picking up there. So I'm going to do the potted history of the history of architecture, 10,000 years in about 4 slides. Okay, so this is the whole thing. Now, this isn't the standard history. This isn't about temples. This isn't the kind of the rich history. This is kind of the everyday, this is vernacular history of the world. And then this is where it is full circle. And this is the bit I think we've all forgotten, we keep forgetting. So got the planet there, and oh my goodness, what, 10, 20, 30, 50,000 years ago, goodness knows, at the point of creating shelter, this kind of human condition of actually we naturally sort of use the things around about us to actually create shelter for ourselves. That's kind of unique. Well, it's not totally unique. I mean, I think that some of our kind of sort of 8 cousins actually do that, but we are kind of pretty adept at it. So got to the right there, or your left. We've got the Black House, which you all know. I think the people over the studio that's doing the over in the Western Isles is like know that quite well. Now that's basically there's not much out there. So again, what do you have? You've got the kind of the stones round about you. You've got the earth, and then you've got in terms of a little bit of timber for the roof, and then you're trying to use that the materials at hand in the most economic way on our winds pretty regularly. So the design of the building, obviously, as we know, is all based on that. So it's environmental determinism. So we've got that. Then we kind of move to Italy, and then the climate's been lovely in Italy for many thousands of years, and you can understand why perhaps there's maybe less population in Scotland than in Italy. So it allows you to kind of do a lot more variation in terms of architectural form, and obviously, but that really kind of built up this kind of courtyard type architectural form, the atrium. Which we think maybe now it's a glazed space, but obviously back in the day, it was actually a place of actually creating a sheltered pool of cool air. So you create your shade, and then you create sort of often with kind of planting in the middle there or water. And what you're trying to do is cool that air and contain it, and you create this kind of little swimming pool of cool air. And that's your place where you actually sort of are comfortable. So instead of actually trying to kind of keep the heat in, you're trying to kind of keep that cool thing. And obviously that kind of form really extends right the way through the Middle East. And the whole thing there is obviously you've got really baking temperatures. The winds are quite, in terms of hot winds. So in that case, you're trying to shelter yourself from that sort of environment. And really the whole thing about the hanging Gardens of Babylon and things like that, all back through the history. It's all about creating this kind of sort of microclimate. Then you go to, this is kind of Pakistan, this kind of example there. And for me, that's kind of the high art of wind catchers. So there's a whole kind of tradition in the Middle East, which is then using, sort of picking up cooler winds or air at high level, and then funneling it through to then cool the individuals. And then a lot of history in terms of actually that you take sort of cloths and different materials, you soak them, and then you actually hang them inside the wind catchers, and you get evaporative cooling through that as well. So there's a lovely history, fantastic history, beautiful history. But actually the architectural form is actually really derived from that necessity. So necessity is the mother of invention. And actually for me, it's about that expression, that basic expression of architectural form, which then kind of builds in culture and so forth. So that's a fantastic example. Flowering, unfortunately, I'm not sure how much of this has actually been retained in Pakistan, really. But yeah, again, this is right in the day. And then finally, to the kind of extreme other side of our climate zones is actually sort of hot, humid countries. Obviously, we've got the kind of the sort of Southeast Asia, and that is difficult. That's really difficult because then you've got really hot, and you've got really humid as well, up to almost got 100% humidity at many times. And if you've ever been sort of on holiday there and not in an air-conditioned space, then you'll know what I'm talking about. It's really difficult. I'm not built for that, definitely. But the architectural form, again, is taken different there. You can see this is raised because of the flood levels in terms of where people were living. And materials at hand as well. So this is kind of lightweight, rapid renewables, kind of bamboo or reeds or whatever. And it's designed to allow the wind. So you want to go up above the flood level, but you also want to get to a point in terms of above the surface boundary of how air moves along, the winds move along the ground, and you're away from that radiative heat as well. So what you're doing is you're sleeping high up, almost in the tree house, where that wind's going to kind of come through you, like keeping you cool. So really, that was it. That was kind of sort of 10, 20,000 years of history, but quite sophisticated. But for me, that's the basis of architectural form and architectural vocabulary. Then obviously you move into the kind of more classical sort of side of things. And for me, there's a straight lineage in terms of neoclassical, but right way back through obviously to our Greek and Roman domus. And this is Edinburgh. So I'm going to skip through a few thousand years there. And for me, this is kind of the high point, really, think of, for me, daylight in architecture. It's we're creating a comfort. So it's moving from just basic shelter, and we're really creating a lovely environment for ourselves now. And then, it's all about the windows, the proportions of the windows, the size of the windows, the way they're positioned in the wall. And then you create some beautiful interiors. So this is in Charlotte Square. And even to there, this is the most desirable parts of all our UK cities, the Georgian parks, or maybe early Victorian as well. They're absolutely beautiful to live in. And obviously, in terms of heat, they're a bit uncomfortable sometimes, but for most of the year, I think they're absolutely beautiful. And then the daylight is important. Now, this is the whole thing. The daylight is absolutely critical. The high part of the window, you've got to see the sky. If you don't see the sky, thin, long windows really don't work. Okay, so that's maybe a provocative statement, but it's got to be the high, tall windows is where we've got to go. And then through to delight. So this is kind of obviously Louis Kahn. This is where it all kind of comes together, where you got this kind of materiality, this kind of daylight, the sunlight, and you're creating this kind of inviting place just to go and sit there at that moment. And you've got little kind of little window there. You can sort of open and close. You've got your fireplace. And that's where for me, that's kind of where this is all going, this environmental determinism, this design using local materials from the area, and then you create that kind of sort of ecological design. That's really where we're going at some point. And then all of a sudden, basically new materials, new machines. So this is a kind of building. This is the Salvation Army headquarters, Kabuzi in 1929. And this is as a design. So I'm just picking this one, but you can use any examples in terms of kind of for the modern era. But this one's got a particularly interesting story. So obviously designed, you can only really sort of design that with reinforced concrete, glass, steel, and air conditioning. Okay, so the amount of glass on there in Paris, again, that's got a south-facing facade. as well. And there's no surprise that they had problems running it. This is early days of the carrier air conditioning. So again, they couldn't afford it. First off, the electricity, it wasn't working very well. So it kept breaking down. So they had to kind of obviously get the air conditioning people back in. And then really the whole thing, it was too hot, obviously in summer, as you see, and too cold in winter. So what they did was they got Corbusier back in to do a sustainable retrofit of one of his own buildings in 1952. And he stripped out a lot of the air conditioning, and he actually designed a shading system, brise soleil, tuned to the orientation, really created more opening windows, again, used kind of sort of local stack effect windows, low level, high level, and then actually reworked the building at that point. So for me, this is the salutary lesson. Unfortunately, this is what we're doing again. This is what we need to do now. And that lesson was learned by Corbusier at the end of his career. And we'd all forgotten about that until I read it in this book. And then a lot of people obviously use this example quite a lot. So, but it's a lesson of our time. Have we learned anything? I would say no. This is London, obviously the Shard. I mean, it is a lovely building. It's a really beautiful thing. I get crystalline towers and these sort of, from early days. It is beautiful, but it doesn't really work. It doesn't solve the problem. It does it better. Again, that's got triple facade. It's all kind of sort of very complex, high performance glazing. It's got really fantastic, efficient air conditioning systems, but it's sealed, and you can only go so much way. The architects and the engineers have done they've done a lot of work in terms of looking at the embodied carbon of this, and it's better than you think, but it's nowhere near where we need to be. So the net result of this, and really, again, the last probably 50 years, is this. This is 2018, so we emitted 37 billion tons of CO2, and 40% of that is from what we do as architects. So, which is kind of quite shocking, really. And the Earth, and this is debatable, the Earth at its best can only absorb half that. But I even think that's debatable. And as we know, it's all been a COP. At the same time, we're cutting down our lungs. We've lost 1 trillion trees over the Industrial Revolution. So hence the new thing in terms of we need to replant 1 trillion trees, just to balance where we were. Okay, and then obviously this is a really sad example of the Amazon. And the consequence of that, we all know, is 1 in 100-year events, or even 1 in 1,000-year events, are happening every few years now. And this is all going to be predicted by the climate model as well. So everything we see now has been predicted. And so I was working on some of this 10, it's been around for 20 years, the modeling. Everything is actually coming true. Floods that, again, 1 in 1,000-year floods are not uncommon now. We've seen that, I think, happen this year in Beijing, Australia, I think that Germany as well, and also in New York. So that's 3, really, really sort of, statistically very rare events happening around the world at the same time. And so this is what we've done. It's exponential. This is what we've actually pumped into the atmosphere. And you can see there, there's kind of balance. We hit sort of the point of when we start to kind of use coal, steam power, 1850, around about there, and then big push into the early sort of 1900s. But then from 1950, you can see the exponential growth. And that's where we are. So 37 billion tons, 2018. Last year, we think we kind of maybe reduced it by about 5%. But again, we're surging back, and it looks like this year, the next year, it will be higher. We're going to break 40 million tons of carbon, I think, easily enough. And that's basically what COP's all about. How do we take that peak, and then how do we get back to a balance point with the Earth? So there's a couple of scenarios. This is the one that sort of we were all hoping for. So this is actually the trajectory to net zero by 2050. And we've only got 29 years left and counting. Now, that is called the Code Red budget. I'm sure if you've looked at the IPCC report, we've only got 500 gigatons to emit until 2050 in order to hit that figure. And that is the figure which really sort of keep us closer to 1.5 degrees increased global temperature. So so basically it's a code red budget of 500 gigatons for the planet. That works out, done the kind of calculation, works out we've got 67 million tons of carbon per year for the entire construction industry and every one of our 45 million buildings in the UK. So how do we do that? So that's the challenge. And that's really the challenge. You guys, when you're going to graduate, unfortunately, you're going to be the point. You're going to have to deal with this. But hopefully we set some good actions for you to kind of sort of work to. But in reality, this is, I think, unfortunately, I think this is going to happen. We've seen that sort of trajectories, and I think that 20 years ago there was a concept called Contractual Convergence. So we talked about this. People are really concerned about how to get the equitable reduction of carbon and allow developing countries still a chance to develop, right? Because that's only fair. We've had our time, 250 years of coal use. So we've got to kind of balance it up. But again, nothing was done in 20 years. And now that's been the sticking point of COP26 this year. And so what's happened is India 2070, 2070, and then obviously China 2060. They're the biggest amounts of emitters. And so what's going to happen is, I think, hopefully it won't be as dramatic as this, but it will still keep rising, I think, for the next few years before things start to kind of level off and kick in. And then we'll come down. We need to come down. Generally, so what happens is an S curve. So you start off kind of fast, but you slow up, start fast, and then you level off, and then you actually sort of then diminish and return right to the bottom. So I think we're going to struggle to hit the 2050, and I think we're going to struggle to hit the 2100. And you can see if that's 500 gigatons, what's that? That's a big question. Rough look at it, it's triple the amount, okay? And then the consequence of that, then what is the temperature? So these are all the various kind of things over the years: very high emissions, high, intermediate, low, and very low. And so this is all from the IPCC report. And where COP sits is between 2.4 and 1.8. But I think once all the modelers really do all their kind of crunch the numbers, I think it's going to be towards the 2.4. I can't see us breaking below 2, unfortunately. So I think once that realization is done, then hopefully next year we can see some more concrete action. So but the whole thing is even 2 is double the amount of what we've increased the planet by the last 100 years. So think of the problems we're having now, and it's not directly proportional, it's exponential. So the consequence of impacts are going to be 4 times, 10 times worse based on the doubling of the temperature. So we're still heading in the wrong way, not fast enough. So, I'm a little bit more with Greta. I think it was a great conversation. The energy in Glasgow was fantastic in the blue zone. I think nobody else, I think the delegates couldn't have done any more in the blue zone. And equally, obviously the energy on the street as well with the rallies was I've never seen Glasgow like it. It's absolutely amazing. But there's that disconnect still. And I think that the bit that's really missed is our government, because they didn't really put built environment at the top of the agenda. This is the single highest, built environment is 40% of the global emissions. So we should have really started the agenda with that. But Boris was saying it's cars, coal, cash and trees. So he's trying to do it by just generating green electricity, and we all can carry on as normal. So we can actually just plug a heat pump into our house and buy a Tesla. That's it. It's a problem solved. It isn't, as we know. Anyway, there's a lot of work to do. How do we get there? Right, so that's that first thing. So I would say, just in terms of COP, hopefully that you were all glued to your screens. I think it's the best that could have been done. I think the agenda was set slightly wrong. So again, I think it was always going to be difficult to achieve that outcome based on the agenda of what was done. And they missed this entire thing, which we'll come on to in a minute, that the work that the construction industry, like myself and others around the world, through the lockdown, we've all been having conference calls around the world, and we got ourselves sorted. So we've got to have a plan how to get net zero by 2030 for buildings. And that's what we're going to talk about later. But anyway, on to the next thing. So what about me? And then how have I come to this point in my career? So First thing is, I'm obviously from Aberdeen. You'll notice this is the Imrie stone circle. And then this is where, coming back to this thing architecturally, and it's just naturally, you take the context around you, and that sort of helps you to form who you are. And for me, this is it. This is about this kind of sort of, it's the local materials, it's from the earth, right? So this is where all my architecture kind of comes from. The idea of actually sort of dropping someone down and building a lovely spaceship type thing, and Buckminster Fuller in the old days, that for me is the way my kind of sort of my head is wired. So for me, it's about this kind of sort of closeness to culture, closeness to the context, closeness to the earth. And I put this one up as well. So another strange thing in this one, but I was fascinated by this as a kid. So this is kind of sort of St. Michael's Mount. It's actually the French side version. So it's an island, but I used to be fascinated as a kid, used to sketch it, when I was, sort of 10 years old or whatever. But for me, this is kind of thing where it's, again, this thing where it's growing from the earth, it's using materials around that. And it's kind of sort of this organic type design. So this is kind of very much struck me as a kid in terms of my architecture. And it's kind of this thing about gravity and about this heavyweight thing, which we'll come back to, heavyweight, lightweight architecture. Flip side to this one, this is that completely, obviously different thing here. So my old man, he was an engineer. So this thing about architecture and engineering is very important. And I think we don't, we've got to watch the silos. We've got to really, we can't solve this problem just by ourselves. We've got to embrace engineering, and we've got to really understand and have the same language. At the moment, we don't really speak totally the same language, but we've got to speak the same language. Anyway, my old man, in his last bit, he designed platforms. So this is actually his platform, Brent Delta. And again, even at the time, I used to give him a hard time as a teenager, saying, "Dad, what are you doing? This is not good." And so this was the end of it. But so it's quite poetic. You maybe can't see there, but we've got a wind generator at the back, and we talked about that back when he was designing this. Is the idea that one day we're going to get rid of this, and it's all going to be wind. So he was embracing that at the time. So I think that the idea for me is architecture and engineering have always been kind of the same thing. It's different facets. We're going to embrace that. It isn't just about high art. Then moving into other things. This is kind of really quite patchy. So I mean, it's quite odd, maybe a little bit left field. But again, it gives you an idea of actually when it comes onto the architecture, where it comes from. So we've got a Victorian hospital design, natural ventilation. And then I sort of ended up studying a lot of natural ventilation and the early origins of ventilation. And Victorians really, really had it down to a fine art. Absolutely amazing, amazing things. Led by surgeons, by doctors, because we were slowly killing ourselves with coal gas. So again, people were dying with consumption, was called then. So again, the doctors worked with architects to then design ventilation systems in Victorian buildings to then make that kind of sort of healthy internal environment. And then my old man, he was the engineer for Aberdeen hospitals. So again, as a kid, I was in the basements. The most, Victorian hospitals, fantastic sort of tiled ductwork underneath all the Victorian hospitals. Unfortunately, all gone now, but amazing stuff. So it's this thing about where, for me, it's about the building's going to be beautiful, but it's got to work. It's going to be useful as well. So again, that functionality is very much part of it. And then this is the termite mound. So, and I only found out this the other way. There's an engineer which you've got to invite up, really. His name is Patrick Bellew. So I don't know if you've invited him up before. No, Patrick Bellew. He is one of the best engineers. And we've got Atelier 10 is his practice. And so, he is the go-to person for architects to work on net zero buildings. At the same time, we both watched, there was a David Attenborough, Life on the Earth, about 21 years ago. And then he went in and actually went into actually put cameras into a termite mound. And that both, at the same time, I was totally amazed. And that's what got me into really into natural ventilation, but also Patrick Bellew at the same time. So we're watching the same thing. Obviously, we didn't know that at the time. It's the most sophisticated natural ventilation system ever designed, right? We can't come close to it yet. Okay, it's basically, it's using paper. So the termites make paper, And the product is actually rainproof, but it's breathable. So it's a breathing wall. And the way they design the system is basically allows a heat recovery system and a humidity recovery system. And it's all based on natural forces. So Patrick and myself, I've been trying to design this in real time for my entire career. I haven't came close yet. I'll get there eventually, so it won't be long. But anyway, these two things, these are things about driving architecture, driving a different form of architecture. And then coming back to our vernacular, these are some of the wind catchers. This is, I think, in Iraq, this one. And then coming back to this one, so again, coming back, it's about forming architecture from basic things. It's about how do we move, how do we take air through our buildings, and then how does it express itself in its architecture. So again, that's part of it. The other part of it is how do we actually like to daylight our buildings. So before all of the kind of this, we had to really work hard and tune our buildings to daylight. And obviously this is kind of probably one of the most famous buildings to ever daylight. Singular, ocular, it's open, but the drama is absolutely amazing. Interesting, the concrete as well, again, uses kind of pumice stone, a volcanic stone, and a local mix. And actually that was the invention of concrete. And actually it is actually the stuff that we're analysing now to make cement-free concrete. So this is kind of more sustainable. And then going into Sir John Soames Museum in London. If you haven't been here in London, please go. This is an essay in daylight. It's basically a tight urban site. And then every type of device, every type of strategy of daylight is in this building. This is that kind of courtyard. And obviously collected, obviously, all kind of curiosities from around the world. But again, the whole thing is the forgotten beauty of a roof light and how that activates the space, creates that poetry. So for me, this is this thing, it's about local materials. It's about how we ventilate, how we form that buildings, and then how we daylight. And for me, to start with daylight, because if you get the daylight right, then everything else follows. Because you can use, wherever you've got a window, you can make that an opening. And then the two go together. And that's where you're using passive design, all that principles to kind of form that basic building. So back to, I was in your seats 30 odd years, 35 years ago. So I was there, and so at this point there was two things. This is my education. So it's kind of me, so it was Rob Webster, and obviously you'll recognise this a facsimile of this building across the way. And I've learned to appreciate this building. It's taken maybe 30 years, but I've got there. I think it is beautiful. It's very sort of simple, elegant, really economy of materiality as well. So I get all that, but in the climate, it never really worked in Chicago for most of the year. Certainly never worked across the way. And I think we've really got to think about what is beauty. Okay, we've got to go beyond just this stark kind of sort of quite technical, hard kind of sort of approach. We've got to think deeper. So what I'm really hoping is that the generations that come, you guys, is that you look at beauty of architecture in a different way. So it's going behind that. It's looking at its kind of materiality from a local point of view. It's looking at its impact to climate as well. And then we need to change the way we think of buildings. And obviously there was no thing, obviously, with the architecture. This is my preference in terms of falling water, front light bright. For me, it's got everything in it I aspire to. So again, that's kind of the education side of it. And then really ending on in basically full circles, Zumthor. So when I was teaching back in the day, this is really my go-to in terms of Zumthor. This is basically this poetry of architecture, where it's a high architecture meets, just basic sort of philosophy of how you take local materials in a certain way, and it creates its own place, its own, not trying to do anything, not trying to do anything kind of complicated. It is what it is. And that is, for me, that's the kind of post, that's where the end point is. So from that was the teaching side of things, really. That was where I was trying to teach here, 20 years ago. And really from that, when I went off and did some research, and then we've been talking about this, it isn't just about design. Okay? It's about numbers. And again, coming back to this thing where I do have this kind of side of my brain that is engineering as well as art. So the art and the science, the engineering comes together. And so I do love numbers. And I think we've all got to learn numbers. Okay, so we can't rely, pass the buck over to engineers to then do the numbers for us. We've got to embrace numbers. Okay, we've really got to, so it's the only way we can achieve this net zero. Okay, you've got to understand how, how much does your building weigh? How much does it use in terms of energy, all those things, but you've really got to understand that kind of numbers. So this is my education, my MPhil, and we went into the detail of kind of buildings where you actually asked people. So I went in and surveyed all the people in this building and worked out what was working and what wasn't working. Okay, and there was some real problems in the top floor. People just hated it. They absolutely hated the building to a point where they walked out, right? Oh my God, this is pretty bad. And this is a passive design building as well, by one of the profs in Cambridge. And then I did some salt modeling. So obviously you can do all this with computers now, CFD analysis. It's absolutely amazing. And at the top slide there is a kind of video as well. So I modeled everything. So what you do is salt water falling through clean water is exactly the same as hot air rising. So you just basically, so this is kind of just flip the image around. So it's exactly the same. And you can model what happens in buildings. And so what was happening is actually the atrium, everything was coming up there, and there wasn't enough openings at the top of the atrium. So all the hot air just kept on rising. And then as somebody opened the window on the top floor, then all that hot air then came through the top floor. So that's why the top floor, everybody hated it and actually wanted to walk out of the building. So and then taking this one, adding in sort of different variations of chimneys and things like that, then you can see there that I got it sort of working where none of that top floor was actually sort of overheating, and that would have been a sustainable retrofit for that building. But that's the level of modelling that I think you guys need to get to in order to understand really what it is to design a sustainable building. You can't just do it by strategies and a few sketches. You've got to get into this level of detail. And this was that kind of the thesis project, which was a museum. It was a museum building, and the brief was design a museum building, but you're not allowed any mechanical ventilation or air conditioning. You've got to do it all passively. And so everything was done based on humidity. So if you work with humidity, that's how you can preserve things. So that was the kind of design there. Then further research. So again, this is when I was all teaching here. So I was also doing some research. You'll notice Shell's headquarters building. So I then wrapped it up a little bit. We're working with Oxford Brookes University, profs there, and we studied 1,000 people in Aberdeen and Cambridge. So I was running a field study in Aberdeen. And then we surveyed everybody and we worked out this thing called adaptive comfort. And that's the graph at the top. So everything you've read perhaps about comfort from engineers that talk about 21 to 24 degrees as a linear thing are completely wrong. Okay, they have missed the point completely. And if there's any engineers that still say that, please send it to me and I'll sort them out. It actually changes. So the comfort temperature of inside is based on the outside temperature of yesterday to complicate things. But so effectively that. So regularly what we're trying to do, it takes a lot of argument, is actually 28 degrees centigrade. And this is quite a challenge for obviously us from Northeast, is actually quite comfortable if the context is right, if you're prepared for it. It's called adaptive comfort. So, and we need to get to that. I need to win that argument in every project with every engineer. If I don't win it, then what happens? I need mechanical ventilation, I need air conditioning, and then I get a sealed building for my engineers. So that's a really, really important win. So when you're out practicing, that's it. Challenge your engineers, talk about adaptive comfort, and then we'll naturally get to that natural ventilated approach. Middle one there is taking up that salt modeling to the next level. This was the Olympic Stadium in Sydney, 2000, where we looked at the kind of modeling the entire spaces there with salt modeling as before CFD. And then more recently at HOK University, still recently 10 years ago. So this is the whole thing where Labour had actually placed a trajectory for net zero. So it was going to be net zero for all homes in 2016, and it would be net zero for non-domestic builds in 2019. That's Labour. And so in the back of that, it was amazing. I got all the house builders coming towards me when I was working at HOK, So we're going to create an eco-village, a net zero eco-village back in 2010, 2011. And the idea there was to test all the technology in terms of heat pumps and everything that we're talking about now, and actually test it in a field study. And we're going to get students to pay for the research, because then you'd have to rent a really nice place, maybe younger members of staff as well, and actually renting it, you become part of the experiment. So you actually sort of then go through the kind of post-occupancy evaluation and then working out how things are working. So that's the thing. Anyway, didn't get the go-ahead from Herrick Watt. I think I did try and persuade David to sort of pick it up, but never got far. But we're actually, that's it. 10 years later, we're at that point again. So for me, there was a big thing called the Bonfire of Regulation when the Conservatives got into power in the UK. They burnt everything that the Labour had done previously, and we wasted 10 years, so this decade. So that's why it's so important now. We've got to get it right this time. And then coming back to this point, this is the last slide in terms of all the kind of theory side of things, but you'll see this kind of picking up. So this is of all the kind of teaching and the practice. At the end of the practice, this is where I did this as soon as I joined Hopkins. So basically what happened was I was trying to do my PhD for about 7 years, and then I eventually gave up. And then I was teaching at Edinburgh at that point. And when you get students coming back saying how wonderful it is to work in London, and I was a bit jealous. So I said, right, that's it. So I'm leaving. So I left the profession, or I left academia. And then I went, right, I'm going to go and work. So, and then who would I work with? And then Hopkins was very much top of my list. I'll show you in a minute. So when I joined them, I then rewrote their sustainability policy right at the beginning. And this is it. So triple bottom line right in the middle, you should be all aware of that: social, environmental, and economic sustainability. And then there's these cycles that then spin out, which then actually create, for me, this kind of bigger picture of sustainability. You've got the ecological cycle, which is then about this doing less harm using healthy materials. But actually what it does, it actually creates a better place for us as well. So this cycle of what's good for the planet is also good for us, and vice versa. Second one, it's a worker cycle. We've got to think about that water course in a complete water cycle. We've got to think about how we sort of use it, minimize the amount of water, clean naturally before we put it back into the water course. Then we've got land use cycle, how we actually sort of protect the areas of land which is really important, and then how we use brownfield sites and so forth. Material cycle, use less, that's the first thing. Then you've got to use low materials. You're going to see reuse materials, low embodied, so long life. So that was that one. Energy cycle, which when we talk about, this is the whole thing about environmental design, microclimate analysis, using sort of airtight insulation and so forth. And you've got your perfect virtuous cycle, which again, we still don't have the evidence to persuade everybody, but the smart money already knows it works. So if you actually enhance, so if you start with the top there, lower capital costs, if you design out complexity, unmanageable complexity, design your builds more passively, you'll save money, you'll actually reduce running costs as well, you'll lower your staff costs, you enhance the productivity of people because they feel actually really a lot more happy in the buildings, and we've got proof of that now. Lower absenteeism, and then you enhance your profitability. So that's a cycle. That was done in 1998 when I joined Hopkins. Moving on to the next thing. So my other thing, which I've been doing the last 3 or 4 years, is chair of the RBA Sustainable Futures Group. So all that thinking in terms of teaching and all the practice I've done, I get my moment to say, right, okay, let's just do this. Before that, there was the RBA, my goodness, they were very polite. I liken the RBA to the BBC. They're kind of very polite, and then they kind of sort of, yes, of course, yeah. So they're all very, but then the inertia sets in. So to get the RBA to do anything, this is really difficult. But everything changed in 2019 because architects declared climate extinction, all this thing about the climate emergency. The external pressure on the RBA at that point was absolutely unbearable for them. But we had Ben Derbyshire as president, who was absolutely, one of the best presidents I think we've had for many years. And what happened is we were inside going, this is what you need to do, Ben. And then outside the pressure, and the two came together, and actually that's where the floodgates opened. That's where immediately our Sustainable Futures Group was taken seriously, and we actually set the policy and the direction of travel for the RBA, which was really exciting. So this came out of this. terms of this declaration of climate emergency, which was a game changer. And out of that 3 years, we've rewritten all the guidance of the RIBA. So we've got the 2030 Climate Challenge, which I hopefully you know about. We'll come on to this in a minute. The RIBA Sustainable Outcomes Guide, which then you'll see in a minute. And then all that is embedded into the RIBA Plan of Work 2020. So as a team, we rewrote everything. And if you go into the 2020 Plan of Work, you'll see that sustainability isn't a separate bolt-on. And it was originally going to be an overlay. We weren't allowed anywhere near the core text. And eventually they gave up and we rewrote it as our team. And then the last one is a plan for use. Now, the plan for use came about is that we've been talking about plan of work for 60, 70 years, but very rarely coming back to this thing about how buildings work and how they're used. That's been difficult in the vocabulary of architects, and that's the bit that's changed. So that's where the plan for use came. All the guides are related back to the UN Sustainable Development Goals, so there's 17 of them. But then here's the thing, there's 17 goals, but if you lift the lid, there's 150 metrics, and then behind that, there's another 300 or so indicators. So unmanageable complexity. So if you try to do that on a project, your head would explode, right? So what we're trying to do is actually pick out what are the key things that we need to know at a project level, and we can manage and measure and deliver. And that's exactly the same as you guys on your student projects. So what we did is we split it in half. So we said that the ethics side of sustainability, we think should be government. That should be absolutely a non-negotiable. It should be ethical what we're doing. The RBA are doing a piece of ethical work just now, which hopefully will be released next year. So we got the environmental and social sustainability. There's 10 metrics there. Then we actually then boil those down, distill those down to 8. So these are the 8 sustainable outcomes. So start from the top, and you'll actually see the cycle here from the 1998 diagram. We've got operational energy use, we've got embodied carbon, we've got sustainable water cycle, we've got sustainable conductivity and transport, we've got sustainable land use and ecology, good health and well-being, sustainable communities and social value, and finally, life cycle costs. So, and I'd forgotten about my diagram back in Hopkins days. And I came up there. So when I was doing this talk I did this talk for Belfast and other places, and I just discovered, well, I've used the same diagram, and it's almost exactly the same. So anyway, you forget about things and you remember them. So what this comes down to is this kind of DNA of a sustainable building, and this is really important. And I think this is where hopefully you guys can pick this up in your project work. So there's 8 outcomes. And I've boiled it down to 24 metrics, 24 things that you need to do as an absolute prerequisite to then achieve our net zero goals. But actually to go wider than this, we've got to create a change the way we think and we deliver things. I'm not going to go through each one, but really we start off there's certain things, and really it's reduction, and then it's actually reuse as well. Retrofit first is absolutely important. But you can see there, that's all there. And I'll send this through to you. And actually, you should have this hopefully on your desk when you're actually looking at some of your analysis of your buildings and your projects, and then see how close you get. So just taking each one very quickly, net zero outcomes. There's no shortage of energy. There's 1 kilowatt per square meter hitting us for half the day, every day. It's from the sun. It's how we actually harness it, how do we capture it, how do we store it? That's the issue. And how do we do that? The first thing is retrofit first. We can't solve the problem by building new buildings. Okay, that's absolutely, we can't do that. We've got to think about fabric first, which, as you know, regenerative engineering, recycling in terms of really efficient engineering, taking that machines out. But when we do it, then it's all about sort of this passive house approach to kind of thermal recovery. On-site renewables, and then when you can't get enough on there, and we can't go crazy, we can't have eco-bling, distorting the architecture of the building. I'm not suggesting that, but we need to maybe have some off-site as well. Then there's the embodied carbon things. The temple here, if you don't know, that's a lot of these are rebuilt every 10 or 20 years, and it's just the same products. They're all kind of renewed. In terms of replacing that, but they're all from local area here as well. And a beautiful story, I was sat next to a Japanese client and talked about even the types of timber, they grow it in certain ways. when the wind comes in, it changes the nature, the structural nature of the timber, and they use certain timbers from certain rotations in the buildings. So it's absolutely beautiful. And really it comes down to that retrofit first again. We've got 45 million existing buildings in the UK, the worst performing in Europe. Okay, so think about that. We've got a lot of work to do, or you've got a lot of work to do in the next 20, 30 years. Circular economy, as we talked about, lower body materials, healthy and ethical materials as well. Sustainable water cycle, going through that, obviously very simple stuff, low flow, leak detection, but you've got to think about beyond this. You've got to think about taking the cycle and really expressing it, especially in your master planning projects. Don't hide the water away. Use that cycle, express it as open water cycles, as ponds, as rills, as drainage, you know, little berms or whatever. And that's where we need to get to. Sustainable conductivity and transport. The most sustainable building you could build, and if you stick it in the middle of nowhere, you've missed part of the problem here. We've got to think about where we place, where we actually sort of build things. So this is important. This is in Denmark, and notice nobody's wearing a helmet. So imagine that in British roads. Maybe don't look too happy, but you know, obviously I do think they are happy sort of cycling here. And the thing is here is blended remote working. The pandemic has shown you that actually we don't need to all commute in all the time, right? So it's blended working is absolutely main thing there. And we've got to build next to public transport. You've got to think about that high quality pedestrian realm as well. Too much, especially in Aberdeen, is actually the road engineers. They design our cities. We've got to stop that. You know, architects, we've got to design the cities. So Terry Farrell, that's it. I mean, that's his whole ambition. He's done lots of projects in London. Get away the engineers, you know, the architects. We've got to think about how the cities actually operate at a pedestrian level. And the last thing we think about is Teslas. Sustainable land use and ecology. It's all about this productive loose landscapes. We're going to leave the site ecology better than we found it. And this is the whole thing, a target of 20% net increase of biodiversity. That is actually part of the target of the RFA sort of climate challenge. Brownfield sites, absolutely, and then obviously increasing biodiversity. Good health and well-being. Really, again, this is it. We're creating lovely places where we can really hang out in the sun, sheltered. Contacts outside, biophilia, plants, absolutely prerequisite. Good density, indoor air quality, which the pandemic again has shown you how critical that is and how unhealthy our buildings are. So good day lighting as well, adaptive thermal comfort, as we talked about, acoustics, all the things I've picked up there, all the things we've built up, those things, it's all there, we all know it, but it isn't done regularly enough. So we've really got to stop and really sort of be serious about this, and pandemic's obviously shown that. Then we've got to, it's not just about the buildings, the places between the buildings. We're creating communities for people. This is Granary Square in London, King's Cross. It's a regenerated area, and it's one of the finest squares built in London in the last 100 years. And this is actually on a summer's day, all the children from around about the community all come in and they all play in that fountain. It's the most magical place. And really, it's all about these principles of urban design, and we as architects should be embracing this as well. This is the fundamental of how we create good places. And then finally, sustainable life cycle. Earthrise, a famous example picture here, and really what it is this kind of phrase, it's ecological footprinting, which is actually we've got to live on the interest of the planet rather than its capital. That's basically where sustainability should be. That's the kind of ultimate goal. And what we're trying to do is balance all the costs of what we do in terms of carbon and money, but we balance it with the added value of what we create in terms of health and well-being, and then the social value of what we're doing. So that is ultimately the basic equation of architecture. So all of that is then embedded into the plan of work. This is the plan of work. Got your outcomes at the beginning. So you discuss that with your client, you discuss it with your teacher, you set your outcomes, you set your goals, you set your targets, and then you integrate that into your design. So you can see there, you're down, the younger, the more junior years, you're generally doing concept design. And I think the final year, you're looking at your brief. So you're doing stage 1, stage 2, stage 3, and a bit of stage 4. So you can see that's most important. We talked about this earlier on, is sustainability is won or lost in practice in that first month. So when the concept is formed, if I'm not in there quick and doing my design reviews and doing analysis and modeling, then you can never, some buildings you can never take it back, okay, because you've lost that basic principles of passive design. So really important that you learn those kind of basic principles, get it right in there at the beginning, otherwise sustainability and net zero won't happen. And the final thing is then in terms of construction, so we hand over everything to contractors and then we actually start to think about how it's working in reality. And this is the other win that happened in my tenure, which is really interesting, is actually making it almost mandatory for a post-occupancy evaluation of every building. So it's all written in. And so what the plan is basically next year, there's going to be a handbook of sustainable design, which has been written just now. And that's going to be launched. It's then going to be mandatory for all chartered architects to actually then take the test of climate literacy. And that's going to happen through 2022-23. Once that's done, then I'm hoping that then the RIBA will then mandate that the light touch period comes in. So that means that every building design has got to have analysis of how well it's worked. It's a game changer. I've obviously suggested that to the RES. I haven't really got a firm thing back yet. So again, I'll work on that as well. But that's a game changer. If we understand how builds are working, then we can get better. I'll leave that with you, but I've tried to distill, and this is for all the kind of all my kind of colleagues and staff and books and air and all the other practices. I've tried to distill in one page a little code of what you need to do when, and that's it. That's basically everything that you need to think about in terms of the DNA of a sustainable building is on that one sheet, and then when you do it. Okay, so again, print that out, have that as a ready reckoner. And then that is the complete cycle. And if you follow that principles, then you're going to get pretty close to a sustainable outcome. Plan for use, not going to talk about that too much, but effectively, you know, as I said, that's going to be a game changer. Really light touch to the end of the year, because you can't go too much detailed that first year. You've got to wait and see how it's bedding in. The people, it takes a year for people to get adjusted to places. So you need a full seasonal cycle, and then it's only second year that you start to kind of tweak things. But it's important we get architects and clients to understand the life of the building, embedding people in. And so we've set the kind of the goals, we've set the whole plan, we've given us all the strategic things, and then the final piece is time. How fast do we need to go? And this is the diagram that we came up with. We're at 2021. And what this is highlighting is for general cycle of the average project in reality is it takes 3 to 4 years from your first phone call from a client or you win a competition through to its completion. So we've only got 2 iterations to go in terms of a practicing architect to get to net zero by 2030. Okay, and then when you come out, obviously, you know, in terms of final year, you're going to be out next year. For the earlier years, 2025, and then you only got 1 cycle. Okay, so we've got to act now, and really it's basically every project that's on your books, everything you do now has got to be net zero ready now. So when you come out to practice, that's effectively what we're saying to everybody. There's no, you've got to start now, you can't wait till 2025, because how are you going to learn all the lessons of achieving net zero? So it's super, super important. I won't go into too much detail on this, it's got a lot of data, but what we've done, and again, this is in the climate challenge, we've defined the numbers that you need to hit, okay, and this is for the entire industry. A lot of kind of sort of balance, so it's got operational energy, it's got embodied carbon, and it's got water use, and obviously got health metrics as well. The pie charts at the bottom is showing the balances. If we start to kind of really get good at operational energy reduction, at a point in time, it will actually flip to embodied carbon, will have more impact in terms of the environment. So this is showing around about 2025, if we do it really fast. The UKGBC, they've done analysis, and they think the point of change will be 2035 is when embodied carbon will be actually more than the operational carbon. But we've got to remember, we can't, because a twin focus, it's got to be operation and embodied. If we lose sight of operation, there's a thing called a performance gap, is that buildings can be double to 10 times more energy use intensive than what you think you've got if you don't follow through. So it's super important, it's that twin focus. And final bit of this section is this, where again, really good fun, is I've managed to get into the sustainability awards criteria. So this is, I've written this with some colleagues. Everything I've just talked about is embedded into this form. It's caused lots of practices, lots of complaints to the RBA. I kid you not. So we've simplified it a little bit for next year, but not much. And then what we're moving to is actually, and this is where hopefully the RBA, I'm going to keep pressure on them, is in 2030, a Sterling Prize winning project will have to be net zero. You can't get a Sterling Prize unless you hit net zero. So that's important. And that's why when I was judging 2019, so I was on the judging panel, and there's an obvious winner. Goldsmith Street, this is in Norwich, and Passive House development really caused a lot of kind of debate in the judging panel. Is it high architecture? No, it isn't. And there's a lot of kind of consternation about that. Is it worthy of the architectural prize, the aesthetic prize? But we have to go beyond this, and this is why I'm saying is the beauty has got to change. The definition of beauty has got to change here. This is a kind of really lovely scheme. If you're in there, it's absolutely beautifully well articulated, detailed, lovely street patterns, absolutely reinventing the kind of the terraced house. It's quite embarrassing a little bit that you've got to reinvent the terraced house, but it actually hit the 2030 challenge. So it's almost net zero, no renewables, it's passive house. There's no PV on that. And the body carbon wise, it hit our 2030 challenge as well. So it was a no-brainer, it was an absolute winner. That's the challenge, that's what we can do. So, right, on to the little moments of how close have I came in my career. And it's, you can see I've tried really hard, but again, I've got to convince my engineers, I've got to convince the QS, cost consultant, they're not on board. And if I can't convince them, I can't convince the client. And it's only when you get a client, an engineer, a cost consultant, and a project manager all on the same page that you can achieve moments of closeness of net zero and sustainable architecture. If any one of those team members is against you, then it's very difficult. So obviously I came out of teaching, and this is my first project in practice. So it's in the parks, it's an ecological restaurant in St James's Park in London. And so the previous building was absolutely, it was gone. We couldn't save it. It was looking concrete, there was no way to save it, unfortunately. So so we redesigned the building. And you can see here, it's an air-sheltered building right in the centre of London. So just a few slides per thing. So what we did is a bit of folding. So we actually folded the landscape over the top of the restaurant, and then all the heights were set. So very strict. It's absolutely. I've never experienced the level of scrutiny of planning landscape. It's unbelievable. Everything that we designed was scrutinized. So the height, we folded the landscape over, and then the plan was actually just derived by, there was at the back, there's some plane trees, London plane trees. We couldn't obviously and we didn't want to knock those down, but we couldn't damage them. If we damaged them, oh my goodness. So we had to weave the building between that, and also the path was laid out by Nash back when it was originally designed. So actually that was a listed curve. So the building design was basically using Nash's curve and the trees, and then the building just wove between that. So this ecology is basically you work with nature, you work with your context. Material, again, I'm talking about the Japanese example. So we wanted a timber that didn't need any coatings. So it could just last for 120 years, and we didn't want any chemicals. So there's only a few timbers in Europe that could do that. And larch was the one we chose. So we looked at lots of different larches, obviously Scottish larch and so forth, but we needed old growth, not old growth, but we needed sort of older trees in high altitude that actually have longer to grow, and you get a denser larch. Unfortunately, a lot of the larch in Scotland is growing very fast, and so therefore it's great for cladding, but actually when you use it structurally, it doesn't have that kind of sort of density that's required. So we had to go to Austria. So this is an FSC forest. We met the family. It's been sort of forestry in this part of Austria for generations. And then for every tree they cut down, they planted 2, and it's a managed forest. So this kind of cycle of actually using timber in a responsible way, absolutely critical. Okay, we can't just chop things down because timber is obviously really hot at the moment, but we've got to be careful. Notice the trees as well in terms of talking about the Japanese example. You can see where it's grown where the wind came. Okay, so the prevailing wind was at the top of the tree there, and then the leeward side a little bit open. So again, that Japanese story of actually choosing the timber right down to the kind of grain of the timber. So anyway, beautiful timber. I'm getting sidetracked. This is it planked up, ready to go. And this is the finished building. So if you've been in London, it's open, it's got a lovely cafe. Oliver Payton of the Great British Menu, he runs it. So go there, have a great time. So you can see here, we're trying to layer the outside, again, using all those principles of passive design. It's facing the view, facing the sun. The terrace is then the overhang, it's the shade. And then it just naturally kind of sort of engages with the public. So you can see there, we're making sure all the kind of moments where the people can touch the building, sit on it, use it. It becomes a big park bench, basically. It's been up for about 20 years now. So, and we can see the terrace at the side there, this kind of layered effect. And layering and passive design is very much a strategy there. And right at the back, roof lights there, creating a lovely quality of daylight right away to the heart of the building. Little detail there in terms of we use stainless steel. So these products are designed for 120 years life. And this is the inside shot. And again, it's naturally ventilated, the actual restaurant area. Obviously, the food area is mechanically ventilated, but we use that to then take the air through, and that's the makeup air comes through the restaurant, and that's recycled as well and put into the back of house areas. And that's the finished shot there. So obviously that was 20 years ago. I don't have a shot to the finished bit. It's looking, so we say it's not silvered. We'd love the idea it goes silver, but in cities, because of the pollution, it goes a little bit dark, but you can actually clean it up. There's certain products you can clean the timber. But anyway, that was my first project back in practice. Very proud of it. And as I said, I joined Hopkins, and I had a good choice of different practices, but I really chose Hopkins because philosophically, you can see they hit every button of what my architectural philosophy is about. I really share that philosophy. And this is one of those famous early buildings at Inland Revenue in Nottingham. And it's actually a natural ventilated office building using the stair towers as chimneys. So again, everything about it, I studied it as part of my MPhil as well. So beautiful. And then the back of that, then I worked on Jubilee campus. They actually did this, took the old Raleigh bicycle factory. So it's a brownfield site, and then they created a beautiful campus called Jubilee, and it's absolutely fantastic. And this uses passive house breathable technology. It's chopped up newspaper, and that's the insulation. So it's all very low embodied carbon on the outside, but it's concrete. Okay, and we'll come back to the reason why it's kind of concrete in a minute. But it's important, that balance, which we need to talk about. Got wind catchers as well. So again, all that sort of idea about how you sort of take the wind and help the mechanical ventilation was all there. And this was the sketch, and this was kind of the final design. And you can see they're absolutely beautiful. It becomes the expression of the architecture as well. And this is the final shot. And that was the third phase, which I worked on as well. Unfortunately, the budget we had, so I started off saying, we're just going to build another phase, aren't we? And the client went, no. It was £1,000 per square metre at that time. That was a few years ago. And they said, no, that's the budget. We got the same budget, but we couldn't build the same architecture for the same budget because it was like 5 years on. So we had to sort of obviously lose the wind catchers and everything like that. So it was a bit of a shame, but we managed to do a very low energy scheme on this one as well. So that's for the business school. Then in Hopkins, one of my last projects were there, flipping through. It was quite a few different projects. This is kind of one that's close to my heart as well. So we won a commission in Arizona, of all places, to design their new applied research building. And it was an ecological and bio-based research building. So they took 30 of the departments, and it was all about ecology. And they wanted the greenest building in the world. That's the brief. The brief was that. Right, we went to greenest building, so that's great. Right, okay. Obviously, I did do a calculation of my travel over on British Airways, and then it basically was 0.1% of the energy it would save if we got close to the net zero on this. And this is about 15 years ago. So this is where the thing about, again, we should all obviously fly less, and that's definitely it. But the big prize is this: all the effort we're doing, that's it. If we concentrate on getting this right, then we can save the planet. You can save the planet. So same principles. Sorry, this is the site. It was a flood detention basin. I got San Francisco Peak, 14,000 feet above us. It was a beautiful site, but it was a bit of a forgotten site. And so we just recast it. This is the sketch I did before the interview the night before. So I've been doing some sketches, and this kind of sort of sets up this kind of environmental diagram. So hopefully, an environmental section is probably the most important drawing or diagram you need to do to understand how your building works from a sustainability point of view. So absolutely, in Wilkinson Air and obviously at HOK now, I insist that every team does one of these diagrams. And if it's not right, I can see right away. This was designed, so creating a flood basin, keeping that there, but using that as very much part of the environmental design of the building, and then wrapping the building around the north side of the site to create an entrance to the site as well, but also tuned because the early morning sun was actually better. That's beneficial for this area. You didn't really want the kind of afternoon sun, so that's how it's kind of sheltered and facing towards that kind of southeast location. This is kind of the street and the line level. It's all about this kind of community come together, very much like the street you got there. But really, sort of all the research departments, instead of having corridors on the inside, they all face down, almost like shop fronts. And this is the section there in terms of when we come close to finishing. And then what we do, or what I did in Hopkins, we referenced obviously our own buildings through the bottom to explain to clients how this kind of vocabulary kind of came about. So you look at the one at the end there, that's the steps in front of the Dynamic Earth in Edinburgh. Then we've got Evelina Hospital, and we've got Norwich, and we've got lots of different buildings there. And it's all integrated into that one section. And this is my environmental sheet. So I had great fun with this. Everything you think about, all the sustainable outcomes, that was all considered right in the heart of the design of the building. This is all done, at concept stage. Okay, so this was the presentation we gave just a couple of months in. That was kind of working models, and then this is the finished building here. So that's before and after, and that was just when it was nearly finished there. As you can see, the landscape hadn't taken yet. And and again, the tuning is basically the glass is there, obviously it's an atrium, but the tuning, so it's very much kind of sort of tuned to the area. The with engineers, and we studied the actual length of the shading that need to happen to then get that balance. Okay, so that's all been sort of engineered very, very, very carefully, and it creates a lovely architecture as well. That's the inside. Again, just a lovely space, quality of daylight, very simple building. A very simple finish as well. Come back to the concrete. So the reason that we use concrete, and I'm still going to use concrete, is that if you don't have thermal mass, you can never achieve naturally ventilated buildings. You need the two. CLT, I think in Scotland, I think it's kind of slightly different. Our peak temperature, 30 degrees centigrade. I think we can get away with it from CLT here. But especially in England and London, you need that thermal mass. Okay, so that's the importance of why we express that. I've always used 50% cement replacement. So again, that's only coming in now. 70% in the ground, 50% in the frame. And we're experimenting with a cement-free concrete just now. So hopefully my next building, which is one in Cambridge, that will be cement-free concrete. So watch the space. Then we used actually this is local timber. I think it was this was Douglas fir that was actually in a forest fire a couple of years earlier, and we got it reclaimed. And the charring obviously charred on the outside, but the inside core of the timber was actually okay. So these blue lambs were made from refurbished fire damaged timber, which is a lovely story. And then happy residents. So you can see there, and the main thing, this opening window is super important. You open it, the mechanical ventilation mixed mode goes off, very simple, and then really sort of a nice quality of daylight as well. So happy campers. And that's the shot at night. And it also did achieve what we asked. This was the highest rated LEED building at the time in the world. Got high score, almost kind of full marks, full things. and it hit 90%. So we never got to net zero, but we got 90% reduction compared to other buildings. So it came very close, but not quite there, not good enough. That then I left Hopkins 2005, but then all that kind of sort of that led, you know, the kind of the research we did in all those buildings kept on, and actually then they created this, which is I think phenomenal building. So World Wildlife Headquarters, passively ventilated, all the things we've just been talking about all there. So, and it's good. It's a great legacy in Hopkins still to this day. Then I moved on to Bennett's Associates, so joined them in Edinburgh, and this is one of the builds I worked on towards the end, towards the handover when I joined. If you've been in Edinburgh, please go and see this building. It's you know, absolutely most beautiful building I think I've worked on. It's again concrete frame. It's using panelized system for Belgium, highly insulated, airtight. All the principles we've just been talking about there, but it creates a lovely piece of urban design. Hopefully you agree. Basic principles about daylight. So we talked about this. So really simple. It's basically, you know, the depth of a floor plate is 2 times to 2.5 times the height of your floor to ceiling, and you've got to have that high windows. Okay, that's the rule of thumb, and that's what this building's been designed on. And we see there the atrium in the centre creates a lovely quality of daylight. Everything else flows from that. This is the diagrams there. Again, I'll give you this so you can use this to reference in your buildings there. All the principles we talk about, but it actually creates fantastic spaces. This what makes this building is this kind of quality of daylight, and got breakout spaces where you can really enjoy the architecture and meet your fellow researchers, academics, or students. And then little moments there next to staircases where you've got little moments where you can have a little chat, a little breakout space. And at the top, you've got the views, and the prof here, he said, I want a space where I can take Bill Gates and have a barbecue with him. So this was the brief, and that's what they got. And I think he got Bill Gates there, and he had a barbecue on there. So that's the fantastic. So a great selling thing for the university as well. So that's that one. Then a little moment here. This is back in 2000. What year was this? 2006, 2007. So this is a kind of study that we did for a building back then, and this is kind of the finished one. You can see some wind catchers there and everything else we're talking about. But it started off like this. So unfortunately, the building wasn't built because there's a thing called happened, the Great Recession came in. So obviously that was stalled. So this was the building. So it was a building that actually you knock down. Really, if you've seen it, you go, it's really rubbish. And it's kind of not very high. It's not very deep. It's concrete frame from the 1960s. You know, generally that would have been chopped, but luckily our client, who's an ex-architect as well, he said, no, I want to keep it, and I want to do this as a showcase of actually a sustainable retrofit. This is 15 years ago. So that's basically what we did. We worked with Max Fordham architects and Max Fordham engineers, who I think still hopefully come up. So they're fantastic engineers. Very simple plan. We plugged on a new core at the back, which then became our stack ventilation system, which drove the entire ventilation system of the building. No mechanical ventilation in this building. Well, there would have been if it got built. So that's the diagram there. That was all kind of the strategies all embedded in. That was the elevation. Very simple clip-on, type of architecture. And then really this is the slide I did 15 years ago. So basically I could hit 75% reduction CO2, trying to get to net zero. Natural ventilation is possible. I looked at the kilograms of CO2 per person per day, because that shows the absolute efficiency of the building. Got A-rated EPC, BREEAM, excellent in that days. And actually it was cheaper than building a new building. So it was a no-brainer. Now that was 15 years ago, and we'll come back to it, but this is what we need to do. This is the bulk of the work that hopefully we will all do for the next 30 years. We'll be reconfiguring our built estate. Okay, do we need, how much new buildings do we need? That's the question. And that's the shot at night there. That's the image there. Right, on to going through the practices. I try not to move practices, honest. I do come in and I say, right, I'm going to be here I want to retire here, but just inevitability happens and you just got to go with the flow now. So basically it's when you're going into practice. So I think there's very little a job for life now, but really if there is, grow in a firm, it's all good, but just embrace the change. And I really enjoy working with different practices now. So because you learn so much more. If I'd just been at Hopkins, I would have just learned to do the Hopkins way for 20 years. But my experience in other firms has been amazing. So just a couple of schemes here. This is Dyson's headquarters building in Malmesbury, just outside Bath. And we did a lab building for them. So this is all the new technology of Dyson, all pre-IP. So it means it's so secret that basically, to get in the building, I can't even get back in the building now. Okay, so it's so secret. All the new inventions he's making is in this building. So labs in the middle, and then actually put the offices round about the outside. When I say offices, these are kind of little studios. And interestingly, Dyson operates. Normally, a research is all about collaboration, and you want kind of teams to work together to create new things. He operates it slightly differently. He sets the same task to 2 teams separately, and then he uses internal competition. And then that's his desk, sort of in the middle, the top floor there. And then the teams then come and present to him the product, and then he'll crit it. And I think he was quite gentle with us, but I think he's got a reputation. But that's how he's obviously worth £10 billion now. Anyway, so that's the kind of plan. That was our early kind of visualizations. Now, the story of this is kind of quite fascinating. So it's basically that I was working with Chris Wilkinson, who is a fantastic architect and really, total respect. But it's interesting, he's from a different age, he worked with Fosters, very much collaboration with Fosters. And then he's from this kind of generation of Mies and this crystalline architecture. And again, he's got the Crystal building in London, which is a fantastic building, but it's an essay in glass. So he really is very much kind of sort of trying the poetry of glass. So he really wanted this as a glass cube. And so that set up a bit of tension. So I did try and convince him to maybe not have all glass. And you can see I didn't win that argument. So then it became a thing, okay, how do we make, so it really became a challenge for me. How can I make this as sustainable as I can? Because it's an all glass building. And I thought, oh my God, so this is difficult. So anyway, so it was a glass cube, but then I was allowed to do natural ventilation and a bit more passive for the cafe, which is next door to it. So that's where I was going, I'm happy, at least I've got that. That's a section through the middle of the building, this kind of street, and that's where everybody kind of came together within that type of diagram. And that was kind of the view of the cafe. Notice, just before we're going to go to tender, James said, right, okay, I've got an idea. I've got this jet fighter that's sitting in the car park. Can I put it inside the building? Right, this is just broken shit. So it's Bureau Happel with the engineers, and said, right, let's have a go. So we managed it. So actually, that was us doing some of the tests. It was a lightning jet fighter that we hung from the ceiling. And this is part of the inspiration of Dyson, really, is that he has British products, British inventions. The most famous invention you can think about. He's got the original jet engine invented by Whittle. He's got but he cuts things in halves. And what it is actually displays everything. So actually, all the engineers are inspired by things that are beautiful, but actually useful, creative, things like that. So that's basically partly the thing there. So these are the kind of studies we did. And this is the final build, so that's that same shot. And interestingly, so you can see there, the glass is a golden rectangle. So I don't know how close, I think it's probably pretty close. It's completely sealed. And the way we justified it in a way, post-rationalized, is the reflection of nature. So again, it only worked because actually we shielded it with trees right the way around the building. Okay, so the landscape, on the other side, it was actually new trees, but once it's all finished, it's going to be enclosed in a microclimate of deciduous trees, and then it reflects that nature. But then the amount of engineering done to this to make it work, the performance of the glazing is beyond, and that was the most. I mean, they had to get special glass from Germany, and the G value. So the G value, the reflective component of this glass, is actually it's a 0.09. It probably doesn't mean much, but that is so. It's almost like looking at a mirror, but it works anyway. So that's kind of the beauty there. This is kind of the view of the cafe, and then obviously creating places for people really to enjoy, and then big overhangs for shading as well. We'll come on to that in a second. And this is the view of the building there, so you can see it straight on there in terms of its thing. Now, the reason it's reflective as well, I think, is this work he's doing here. He's had German, Japanese, Korean companies sending spies to spy on his inventions. So that's why it's partly that as well. So really, that whole thing is you can't see through there. At night, we'll come to this, it does become see-through. So we've actually, part of the environmental strategy is we've got automatic internal blinds that come down that are reflective. And actually at night, they come down and they shield people working in there. But they actually serve a purpose. This is the only way we can get it through building regulations, because otherwise too much glass. So the whole thing here is basically we solved it. But I said to Chris, this is probably the last time you'll be able to do a glass cube like this, because the technology, the building regulation gets so much tougher that you won't be able to do this. So it's kind of a very interesting tale. And the strategy we worked, so it was basically, we used active heat pumps. So again, we basically got James to agree to build the largest ground source array in this part of the country. So basically, you drill boreholes into the under aquifer, and then that's how you heat the building and cool the buildings. And so we built it, it's absolutely massive, and it does the entire estate. So it's 4,000 workers, absolutely massive estate. So it's all cooled by the earth and heated by the earth. And we put that through chilled beams, and that's actually where the ventilation comes in. So anyway, but actually, the whole thing is there is I always get a bit twitchy. So what I do is I say, okay, I'm going to supply, but you can use natural ventilation to take it back. So you don't need to do to supply and extract by mechanical means. You do it once. You either supply by mechanical and let nature take its course, or you actually can suck it out. So this is actually sort of blown in, and it goes back into the labs, and then it's recycled. This is our cafe. So this is it. There's the fighter jet in there. Really happy with this space. It's really obviously quite glassy as well. But in terms of its kind of free running nature, and again, picking up that idea of the earlier cafe back in St James's Park, obviously on a larger scale, and all this shading was tuned exactly to minimize the amount of heat gain on there. And you can see a little bit of ducts kind of popping in there. I was insistent that I was trying to make this naturally ventilated, and this mostly is, but there is a bit of heat recovery at the top there. But fantastic space to that one. And then just the level of detailing. So this thing where about using necessary forms and systems, but you make them beautiful, and that's the architecture. So none of this is willful, none of this is like an applied decoration. It is just taking things you need, and then you make them beautiful and make them part of the architecture. So really pleased with this particular detail. And that's going to be overhang towards the west. And then little thing there is a little sports centre. This was kind of a little thing there. The story of this one is kind of quite interesting, if I just go through this inside. This is the story of engineers. I didn't have a very good engineer on this particular building, and he was insistent he was going to make this fully mechanically ventilated. And I went, over my dead body, there's no way you're going to achieve that. So we argued for a good couple of months, but I got my way in this one. And this is a naturally ventilated sort of sports arena. So again, very simple stuff. Vents through the perimeter of the building, and then the windows at the top are automatic. Very simple. It took a lot of effort to persuade the engineer. That's what you're going to be faced with. So again, use that as an example. Use this as an example so you can do it. Okay, on to last couple of projects. This is gas holders. This is in King's Cross. And the idea here is that there's a competition won by Chris, and lovely story. So basically, it's 3 of the original gas holders, Victorian. So this is coal gas. And then inserting in that was basically creating 3 new blocks of apartments with mixed use on the ground floor. And how do you link it together? How do you make this work and make it beautiful? And so you can see there, that's right next to the canal. And this is all the types. I should have taken this one out, but it's the most complicated planning conundrum. So it's like a piece of watch or clockwork. Everything's kind of twisted as well. Nightmare to build. Top floor, absolutely amazing. Views over London, and it's actually looks pretty much similar to this visualization. This is the view of it finished, again, next to the canal. Now, the thing I'm going to pick up on here is the facade. So the aluminium, so it's a lot of aluminium here, which so I was a bit, but I understood the logic. It's very much kind of industrial. It's trying to kind of take it right back to that early days of Victorian and the gas holders themselves. But interestingly, these are perforated, highly recycled aluminium, but they're actually automatic shades as well. So again, the whole system is designed to maximize shading at different times of the day, and it's all automatic. You can do a manual override, but this is, for me, this is like a student competition. This is the one that you really want to win. And it's all automated, and it always got natural life. So actually the building is responsive and it changes over the course of the day and the seasons. And the layering effect, and this is what I was trying to make really highlight to Chris, really is that flat, single skinned buildings really are not the answer. That is the wrong way. We've got to introduce a depth to the elevation. This layering effect is really important. The external skin here, the balcony set back, you've got natural shading, and then you've got the choice of natural ventilation as well in terms of that. It all works together. And for me, it creates a better architecture as well. And that's going to sort of zooming into that kind of particular shop there. And then really just take you through the building. This is going to be the entrance lobby, and then into the atria. Atria, natural ventilated stack ventilation. It basically allows at certain points you can actually open your windows, and then actually that stack effect will take and the huge stack pressure there as well. That will ventilate all the flats as well. And this is the kind of terrace here in terms of internal walkways. And this is one of the flats. So it's quite reasonable. I mean, this is a 3-bedroom for 3 million. So if you're up for that, later on, so beautiful, but obviously it's only a little bit really in terms of that. The actual shape of the plan was interesting as well. It was a wedge, and actually that really helped in terms of that you got quite a compact plan in the inside. So your dark spaces that need some artificial ventilation and so forth is in the inside small, but it opens up and it creates this beautiful effect in terms of the architecture and the way the space flows. This is kind of the seating next to the balcony. And then the shop, which really kind of just sells it, that balcony, that space. And in lockdown, I think this was a beautiful place to be locked down in. So Chris actually bought one of the flats as well. So you can maybe say hi to him if you're in there, okay? Okay, coming on to the last one. So this is the one that I just finished just before I left Focus on Air. This is the law school for City University, just around the corner from the flat I used to live in. And this one was an interesting one. So you can see a glass tower here. Unfortunately, that concept had been there before I got there. And so we're having the same, imagine I was having the same debate with Chris, is you need a glass tower. How do we make it work? And how do we achieve that net zero ambitions? So the U value on that tower is 0.1. So if you know your U values, that is extremely, extremely good. But how do you do it on a glass tower? That was my conundrum. Again, given a problem to try and solve. We solved it, but the cost of that was pretty ginormous, and we had to get a specialist from Germany to do the modelling because no one in the UK could actually make it work from a modelling point of view. That's how complicated it was. So I reinforced this. Hopefully, it's going to get through. Chris, doing glass towers like this is extremely difficult, and the new regulations, it's going to be impossible. And for me, I think it's probably about time. The reason that Books There won this one is that they were the only firm that said we're going to keep some of the buildings. Every other firm knocked everything down, and that was one reason how they won it. Absolutely masterstroke. So the 2 buildings in blue were kept. The other ones were beyond, and they were really sort of in poor shape. You can see some examples there. But that's that one thing. So the sustainable retrofit mantra, really hopefully take that into your practice when you come in there. That is the first thing you've got to say. AG retrofit first scheme. That's it. You've got to do it. This is the plan. So basically, we did complete the urban block, created a small kind of atrium in the centre there, and then really wrapped the space around there, have new entrance, and then actually a lot of the kind of teaching spaces, library towards the Bastion Street. And then kind of breakout spaces towards that, lecturers, sort of studios at the back as well, and an old 1870 warehouse building. This is some of the visualizations. Again, lovely space, all really tight. This is a strongly tight space, but again, it's beautiful inside. It's amazing how you think you need lots of space, but actually you can dial it down, 6 meters, absolutely fine in the city centre, going up, sort of 4 or 5 stories, absolutely, you're going to get a lovely quality of light there. So really tighten everything up. This is a view back there, trying to keep material palette very simple, got the existing bricks and timber, nice kind of sort of stone ceramic finish. And then the Vermont section, again, our team, our part one actually did all these analysis. So lovely kind of sort of diagrams he did. And then really it's the kind of thing. And the other one is the roofscape, is we did, I think Islington used this as their case study, exemplar case study of doing an urban roof space. It's a blue and a green roof. We've got a bee hotel, and we've got bats. We've got everything on that roof right in the city centre. Now, the blue-green roof is very interesting. So it's a green roof with different sedums and grasses. And then what you do is you allow beneath that to flood, to always have 100 millimetres of water. So it's like a swimming pool, which is then helping to feed the plants above. And that's the view of it from the other side when it's finished. So again, refurbished existing buildings. And it beds in really well. And to be honest, I think the tower at the end, an expression, the university love it because it's their gateway building to their campus. So again, that's why it all fits in well. Then picking up those things, final scheme I did for Wilson Air was this one. We won the competition and we won it with the same thing. We were the only team that was going to keep the existing building on the site. And then this client wanted the greenest college, or the net zero college in the UK. So this was our scheme. So basically layering behind all that with an existing concrete frame, which we then just clip things in, very similar to the scheme I did back in Bennett. We won the competition, and unfortunately what happens is basically there's a pandemic, there's a change of kind of, all the way we teach, and therefore it's there's some problems with the site as well. So again, that's all been paused, unfortunately. So it's a bit of a shame, but hopefully they'll find another site. So, and that central bit is the existing concrete core. Again, the engineers we had, O'Callaghan, who do all the Apple stores, all the glass, they are past masters. So we looked to analyze the existing frame. Then you actually sort of bond on carbon fiber tape, and you can strengthen the existing concrete with carbon fiber. So that was the strategy there. So absolutely phenomenal stuff. We clip on new bits of building, and we actually introduce a new staircase in the atrium right in the centre, which becomes, guess or not, our kind of basic means of ventilation for the entire building. We actually did lightweight sort of steel, and this is CLT option timber. But again, as we talked about, we did the analysis and we had to go to precast in terms of the modelling to get that thermal mass, to get the natural ventilation working. Okay. And that was the diagram at the end. So again, that was, you can see all the things I'm talking about all integrated together. Again, this kind of clip-on retrofit, natural ventilation, good daylight, passive design, and we used it was a passive house approach where we'd actually just use. What we said is we analysed the design and said there's only 30 rooms that might need some mechanical ventilation, and we then said, right, you get the domestic heat recovery systems the size of a suitcase. And so we're just going to buy 30 of them to give to the building maintenance person, and they can plug in when they need it. So it's actually sort of, here's your air conditioning system, but actually you only need to use it and plug it in when you need to. All that is analysed. So every building that I do, I keep all the data. So come back to this thing about numbers. So every building I've touched and looked at, and then I plot it on this kind of big spreadsheet I've got. And then I see where I get to. So basically, that 75% is basically really important. That's where we need to get to on site. That's our RRB 2030 challenge. Do we get to that 75%? Then we're allowed to offset 25%. That's absolutely critical. And you can see there, some of the later buildings, you can see come close to that 75% reduction. But generally what happens is you can do it for the basic heating, light and ventilation of the building, but actually the problem is the amount of energy we use for charging phones and computers. That's what's really kind of the key issue now. So that's basically the whole aspect there. And that's doing the same analysis on books and air buildings. And Northwest Cambridge, that actually plugged into a massive CHP engine, which was then powered by biogas. Actually, King's Cross, sorry, that the Argent, the developer, is now converted to biogas. So that is now a carbon neutral. The entire scheme is now carbon neutral. Then on to where I'm now. HOK, I've been there for 2 years. This is kind of some little example of the buildings. The one top left is I've been waiting 20 years to build a building in Scotland. So it's finishing. It's finished, handed over to the client this week. So it's a new research building for Glasgow University. So again, we'll try and get a visit for that next year. So again, through David or through that. So come and grab me and we'll get you a tour on that once it's all open. And then there's through lockdown, we picked up one of the biggest COVID testing laboratories in the world. So we did all that in Teams, and it's finishing, handed over. I think we've handed over all the lab lines. It's capable of doing 300,000 tests a day, PCR tests. So that will be the main lab, which will continue, obviously, after we closed down all the other labs. But that was fun, and that was done in an old warehouse. So again, all modular. Again, low embodied carbon, everything like that. So good fun. And then the two buildings here, one top there is with Derwent in London, and that was kind of a lab-enabled commercial office building. We did a joint design with Pearson & Co. And the one at the bottom was in Sutton. So again, we've been busy through lockdown. But the two at the right here, I'm just going to take a moment there because this is hot off the press, right? So basically, I'm releasing a white paper quite soon. This is the script behind the analysis that some of my sustainability team have been using. So it's using Grasshopper and then Energy Plus, Honeybee, Ladybug, and a program called Octopus, which I've never really used before. Anyway, fantastic people. A lady in New York is doing all this for me. So this is analysing how do we get to net zero and what all the kind of the tools that we use. So we've analysed those two buildings, and we're trying to get to 247 kilowatt hours per square meter for a lab building. The reason it's higher is because the lab building achieves the highest amount of energy because the stuff that they've got to do it quite rightly as well. So can we achieve that 147? And we can. So basically all the analysis, this is just the tip of the iceberg. But through all these kind of different methods, we can get to that 60% reductions, 50% renewables, that's 75%. So that is your target, 75% reduction. If you can get that, then that's where you're on the right net zero. Then we offset, okay? So that's operational. And this is the one straight off the things. I just got the results back through just a moment ago. So we did the same with embodied carbon. So embodied carbon is 1,400 kilograms for every CO2 for every meter squared. So for 2 of your seats, a normal building will take nearly 1,500 kilograms, 1.5 tons to make that 1 square meter of space. Enormous, okay? So how do we get to our net zero? So we've done a base case, which is looking at situ concrete, bit higher recycled content, and various other techniques, but it's a standard building. So and we can get to 800 kilograms CO2 per meter squared. The medium version, ironically, was the one where we thought we'd get better. That was precast concrete with precast columns and a bit more steel. So a bit lighter weight than the in situ, but actually it's higher than the in situ concrete, which was that's a very interesting result from us. And the last one, the green one, is actually at CLT. With a bit of concrete topping, so we need a bit of stability and a bit of thermal mass. So, and we got to 500, which is our 2030 challenge. But that's not the end of the story. Is we do got the results back through. That's just with using timber. But there's a thing called biogenic sequestration. So when you use timber, and if you keep the building there for 120 years, you can then count that. You're taking that carbon out of the atmosphere. So this is actually saying, well, 60 years time, who knows what's going to happen to that building? It could burn down, it could, that carbon could be released back in. But if you lock it away, and this is the calculation, we can do it. That's it. We take off 400 kilograms of CO2. So we are actually at 150 kilograms of CO2 per meter squared. That's the result straight out the calculation just a few months ago. So really, that's a 90% reduction. Now, this is interesting because hopefully we're going to get shortlisted for a building in Warwick. The client there wants a net positive carbon building. And what that means is basically, from this, I can see that actually the most carbon, as we know, is in foundations. So if we actually lighten the entire building, and then we sort of think about how we actually touch the earth lightly, I think we can get to net zero completely. Okay, so that's the next thing. So really excited about that. So that's going to result there. Anyway, finally, I hope you're doing really well. There's not many people nodding off, so it's absolutely fantastic. I don't know about you at home. I hope you've had a cup of tea or whatever that kept yourself awake. This is the final section. So that's me, right? So you can see I've had these moments where I come close. I'm not satisfied. I'm going to challenge myself, challenge the teams. We're going to hit net zero for every project moving forward. And as a pledge to all our clients, we will give our clients a net zero carbon ready concept for every project we do. We've got to try and convince them to then pay for it. That's the next challenge. So anyway, that's me. Now, this is actually what is important, because this is actually showing examples. And I use this as part of the RBA deck that I've given around internationally. So I've been giving talks in New Zealand, Australia, America, you name it. It's all very interesting. But these are moments where we've actually achieved net zero now. This is a net zero house in Nottingham. It's a retrofitted house. It's using energy sprawl and using a passive house type technique. And they can do it. The only problem is it costs £70,000 to retrofit that home. So that's a bit of a problem. But if we do more of it, we can get faster and get better at it. But that's net zero. We can do it. This is Justin Beer Architects. And if you can maybe invite Justin up to give a talk as well. He is the phenomenal passive house architect, one of the first to really kind of take it through. This is a house for a client. He's gone net positive. Okay, so basically the house is generating enough electricity to deal with all its stuff. It's got heat pump and thermal recovery, but it's got surplus to power an electric car. That's what we can need to get to. And not only just on a small house, but we need to scale it up and make it mainstream. And back to our kind of sort of Goldsmith Street in Norwich. This achieved the 2030 challenge at scale, 150 homes at £180 a square foot, which actually is marginally more in Norwich than normal house. But again, nothing compared to £300 a square foot that you pay for building social housing in London. So it is possible. That changed the lives, lifted families out of fuel poverty as well, which is actually another thing which is absolutely totally amazing. That's why I won the Sterling Prize. Scaling up, this is a project Alison Morrison. We're doing a joint venture with them on carbon, so-called Cambridge East. The owners of Cambridge Airport are selling up, or not selling, but they're going to redevelop Cambridge Airport, going to shut it down. And we're going to create the largest net zero scheme in the UK, if not Europe. So that's on the board just now. We're just doing some of the calculations. Anyway, Alison Morrison did a lovely student accommodation in Cambridge, but they never analysed how much it was performing. And I said, well, give me some numbers and I'll work it out for you. Ironically, it's fantastic, 63 kilowatt hours per square meter. That hit nearly our 2030 challenge. And they didn't even know about it, but they know now, and I think they're going to analyse all their work now. But a really beautiful, very simple thing. So it's this whole thing where, again, ecological design doesn't have to shout. It can be very sort of simple, very integrated, very, very kind of sort of contextual. This is exciting, this one. This isn't obviously us. This is, again, Archetype. And it's a joint venture with Hawkins Brown. And this is going to be the largest passive house scheme in London, if not Europe. 550 units, and again, hitting passive house in terms of operational carbon. So really interesting to see how this is going to be embedded in. And schools. Here we go. We're going up to graduate more thing. This is Archetype. Again, I think we had Jonathan Hines speak. I remember last time we were up there, it was about 4 years ago. Jonathan and Archetype are phenomenal. They've been working quietly in the background. So all their buildings, all the schools are effectively net zero. They're kind of sort of CLT in terms of construction and actually passive house using that. That's the real figures, 55 kilowatt hours per square meter. That is basically our 2030 challenge. And that's without renewables. Okay, if they strap renewables on that, that would be absolute net zero. And it's a beautiful school as well. And this was all built, as Jonathan highlighted, is it's all built for no extra cost. So the argument, so this is one of the arguments you're going to get in when you're practicing. Yes, but yeah, you can do that, but it's going to cost more money. No, it doesn't. It's all in the architecture. If you start off with embedding it into the architecture, you can achieve it. Going up a scale, this is the best performing non-domestic building for the last 10 years in the UK. It's Enterprise Archetype again. It's 70 kilowatt hours per square meter. That is the actual energy use. That's with no renewables, no heat pumps. Okay, so that's a pure passive house. If you added the heat pumps on there and you added a bit of renewables, that would come close to zero. Okay, and the most amazing thing is the cladding is actually straw, so it's thatched facade, which I thought was one of the most amazing things out there. So great stuff. Then Field and Clay going up. This is the kind of library in Worcester. 88 kilowatts hours per square meter. Again, coming close to that. Very complicated building. No renewables, no heat pumps. You know, again, this is the sort of things that should be. These numbers should be actually at your fingertips, and that's what part of the climate literacy course is about. And hopefully, we can get URS to kind of sign up to that as well. And then the last one to show you is this one. This is Everyman Theatre. Again, it's about 10, 15 years old, I think, this one. This one is Sterling Prize. And again, you know, here was Tompkin, who, you know, Justin, he was very much, was part of the Architects Declare group. You know, Epiphany, everything he does now is retrofit. Yeah, he won't even touch new buildings now, which is quite fascinating. Anyway, this one, reuse the brick of an existing building as part of the core of the theatre inside. So it tried that, obviously a very kind of lightweight and facade, but actually it was all naturally ventilated. So again, it was using all the principles I talked about right from Victorian times and actually reused it there. And you can see there, it's obviously a large number, 186 kilowatt hours. But remember, theatres and concert halls are enormous generating, they use a lot of energy. So it's really roughly about a 70% reduction. And this is coming back this thing. This should be from now on, the RB Awards, the Sterling Prize has got to be beautiful and it's got to perform. If it doesn't do either of those, it shouldn't win. So just take away, last slide, I promise. This is 10 things that you need to do at your desk tomorrow. Okay. And for the practitioners, 10 things that you need to do tomorrow at the desk. First one is you've got to agree and define what you mean by sustainability. Think about your outcomes. Think about the goals you're trying to set yourself. Okay. And then it's all there. It's all written down. Have a look at the guides. Second one is circular economy. I think that's very much an indicator you use, which is great. It's about retrofit, recycle, and reduce and reuse. Design for net zero performance. It's basically designing with that mind, but you can't do it without modeling. You can't do it just by a few strategies and a few diagrams. You've got to model. You've got to use the computer tools I just talked about. You're going to increase biodiversity, 20% net gain on anything you do, especially anything you're doing in terms of master planning. Think about the plants and the landscaping around about your buildings. Okay, and I remember doing a few design reviews many years ago. Again, isolated buildings with a little bit of a little shrubbery, that doesn't cut it. You've got to think about that. Low embodied and healthy materials we talked about. Well building principles, so it's about daylight and ventilation, very simple things inside, the beauty of the space inside. Passive design we talked about, fabric first, passive house level, which I think was great. I heard that a number of staff are doing passive house training. That's it, really use that as your base level of knowledge. It's absolutely fantastic. Regenerative engineering, challenge your engineers. Okay, so when you're in practice, challenge them. Don't take them, if they're being a bit sort of, shall we say, lazy, they're just using what they've done normally. You've got to challenge them, say there's a better way. The building should do most of the heavy lifting, and then the machine should be just fine tuning. Non-fossil fuel, from now on, no building should have any gas anywhere near it. Okay, that's it, end of. That's it, it's all electric. And then how you actually use PVs, heat pumps actually, you know, that's the next generation. You've got to think about how we're going to do this properly. And then finally, plan for use. Think about how your building's going to be used and operated throughout its life. And that was the last slide, but this is the goal. Thanks very much.